Hello and welcome everybody to this second session of the Hackathon and ITSec Pro event, which will go for around 3 weeks. It's a pleasure for me to introduce Himanshu and Aman. The stage is yours.
Thank you very much. Let me just share my screen, and I hope it is visible. Yeah.
Yes, it's loading. Meanwhile, by the time team screen shares, hi guys, welcome. I would like to thank you guys for joining so early and being a part of this talk. And we hope that you really enjoy it.
Yeah. So hacking 50 million users using 1, 2, 3, 4, 5, 6 sounds pretty interesting, and it was very interesting when we did our journey. It was a 200-day plus journey as red teamers, and that's what we are going to go through today. We are going to share some insights and some interesting findings, that interesting experiences that we all went through during this exercise. So, quick intro for Himanshu. You can go ahead and introduce yourself.
Yes, so for people who were there last time, I would say my name is Himanshu. Glad to have you back. And for people who are joining this year, my name is Himanshu Sharma. I have been in the bug bounty and all this hacking field for about 10 years now. I am in the Hall of Fames of all the top names you can think of: Google, Facebook, Apple, Microsoft, like anything. Any top company you think of, I'm probably there. Then I wrote 4 books on hacking, which turned out to be bestsellers on Amazon. One of them is on Red Team, and 2 of them are on Kali Linux. And one was recently launched, which basically enabled users to do web pen testing using Metasploit. Then, yeah, I'm a co-founder of bugsbounty.com, and I have been a speaker and trainer at various conferences throughout, like for the last 3-4 years. So let's thank you guys for having me again, and moving on to Aman.
Yeah. So, hi guys. My name is Aman Sachdev, and I've been in the security industry for a very long time. It's been almost 9 years now, and I've always been a developer at heart and a hacker by profession. Currently, I'm working as a product security engineer at VMware. Now, I'm finally into the defense side of things. I've been attacking since a long time. As previously, I was in every form of red team there is, mostly specializing in web application and wireless exploitations, as well as I did my fair share of social engineering, campaign architecture, and phishing simulation for around 3 years, mostly in the Asia Pacific and the UAE region. And I walk security, talk security, eat security all the time. So this is just me doing me as always. So let's just directly hop into the show and give you basically an understanding of what exactly we do. So Himanshu and I have been working, as part of Bugs Bounty, InfoSec Ventures, a lot of red teams, where the kind of projects that come to us are somewhat like a company will, a VC would come, or a big investor would come to us, and our job is to be their watchdog. So they will come to us and say, okay, these are my investments. What can you do? What's the damage? Can you do a risk assessment? And of course, living in a non-GDPR regulated area, a VC can actually go ahead to ethical hackers like us and say, okay, show me what you can hack in my investments. I need some peace of mind. And our job is basically to steal that peace of mind, and later on give it to him that, okay, now with time you can have things patched. And that's what we do. That's the kind of projects that we get, wherein somebody would come and say, okay, these are my targets. That's the only information that I'm giving you. Go and see what you can do. And that's what we need. We just start pressing our big red hack button, which is like the only thing you need apart from beer to hack, right? And that's how things are like, right? So this is the story of one of such engagements, wherein a very massive VC, an investor who had his hands into food tech, travel, online food ordering, uh, then a lot of other financial tech, payment gateways, e-commerce, all sorry, all of that stuff. So this VC came to us and said, I want to see these are my fellow investments, and show me like what all things are is all this vulnerable to. And that's where we started, right? The first thing we started was, obviously, we did our reconnaissance, and because we only get the names of the companies and nothing else, we started with our reconnaissance. And one of the first things that we found, like, of course, our teams are divided into separate chunks, and there is an internal war game going on between the teams, who's going to win, who's going to crack it first. And this is this team where we found this coupon management system for one of the food ordering websites where you can order some pizzas and stuff, right? We found this coupon management system, which was the staging environment. And obviously, you see a login page, you something like an admin login page. You try the simple things. You try SQL injection. We brute forced it for several hours. We try several magic tricks and whatnot. And then one of the other teams said, we used a 0 day and we got in. And we're like,
I was the part
exactly
of the
happened?
team. Aman is not telling you guys this. I was the part of the team who was doing all of this and failed for like 6 straight hours. Couldn't find
Yeah.
anything.
So after 6 straight hours, when this could not be found, they cracked in, and the 0 day was demo as the username, because that's what was not being guessed. The password was 123456, and of course it was pretty trivial because it was a staging environment, and nothing critical over here, just some demo stuff, demo coupons and all. But yeah, that's we got into this and started escalating and see what we can do from here. And of course, the first thing that you do once you're in is find an upload functionality, maybe in a web application, and that's what we did. And we were able to get inside the we like upload a simple web shell, and because there was an Excel parsing vulnerability in the coupon system where you can upload,
PHP Excel uploader, I believe.
yeah,
It's called PHP Excel uploader. Yeah.
multiple coupons at once using an Excel, and that had a file upload issue, which we were able to exploit. And it was a fairly simple web shell. Now, from here on, the actual recon starts to see what exactly is happening. And what I started doing, me being a developer at heart and being very close to code, I dumped the entire source code and started reading it, yeah, like line by line, and trying to figure out what exactly is there. Maybe I find something interesting, right? And I did. So there was a very interesting thing in the login mechanism. One of the files that was included in the login mechanism was basically checking if the user is logged in. If the user is not logged in, it was redirecting back, and there's the rest of the code. And I realized this was in PHP, of course, and I realized there is no die function, right? So die kills the code. So the proper logic should have been, if the user is not logged in, redirect and die. But the die was not there. What it meant was that the page was redirecting back to the login page, but the content was actually being sent. It was just being redirected. So we just changed our all of our 302 responses to 200, and we were able to bypass that. So this was eventually, without the username and the password, the login can be bypassed. And of course, once we were able to find this on the staging application, we replicated the same thing on the production coupon management system, and we got in with the same vulnerability. The redirections were not like configured properly. The code was not dying even when the user is not logged in. So it was a forced browsing plus a session mismanagement. And that's where we got into the production and started digging into the production, shelled the production also. And this was the first break in the entire exercise. And that's where we started doing more recon. And Himanshu will tell you what happened after that, which was very interesting.
Yes. So the entire story of this hack is very, very interesting. And so what happened was, once we put a shell, because the code was same, right? We uploaded a shell on the production environment. We started digging for more information, and that's when we read the etc host file, and we found a IP address and a host which pointed to some internal Redmine forum. Now, this Redmine forum was basically an IT help desk for employees where they could, jump in, put a query, something like my system is not working, my credentials expired, my email has not been created, and things like that. So what happened was basically the our we call it our good luck that this Redmine forum, because it was supposed to be internal, right? We could not we could still do a search on the existing posts. We obviously could not log in inside, but yes, this forum was open to public search, and what we did was we accessed that forum through this server, and we started. So once you get access to an internal forum, what is the first keyword everybody searches for? I would tell you, we looked for the keyword password, and we wanted to see what all employees have posted something related to password, and we found a query. A lot of employees have basically written that I forgot the password of my Gmail account. Can you reset it? The response was, hi, the password has been reset to the default one. And the company name at the rate 2019. Guys, this is like, I don't know, no, nobody should do it. Because over the period of my experience till today, we still go to a lot of companies and find this is a very very common practice of companies, because it's easier to remember for the employees as well, be it onboarding process or be it for the older employees. This password is pretty common as being used everywhere. So this is what we discovered, and we basically had a eureka moment. And then we started basically, because we had the password, we basically now needed the email addresses, and so we basically started we wrote a script, and from the entire forum we started fetching all the names of the users, and we basically tried a few patterns to come to get a possible working email IDs, and which actually were valid. So we discovered that after fetching a lot of usernames, we tried first name dot last name at companyname.com. This turned out to be a valid ID combination, and we started brute forcing. So basically what we did was we got into the email account of obviously the first guy who posted this, but then that was not it, right? We tried to log into as many accounts as possible. Now the interesting thing here is, when you try to log in from an unknown location or an unknown device, Google actually pops up. This is very rare nowadays. Google, what it does is sometimes you get a pop up like this. Other times, it lets you log in, and then suddenly the account gets blocked in like 2 or 3 minutes. So in our case, basically it basically asks that something is wrong, and we would like to verify what city do you usually sign in from. So that's it, guys. So we thought we were logged, but then what we did was we basically started looking for the employee, and we pulled up all his footprints on Google, LinkedIn, Yellow Pages, and Facebook. And then I believe it was Facebook where we
Yeah,
discovered his
yeah, it
post.
was Facebook.
Yeah, he posted some photo outside his own office and location, and it was tagged. So there we got the location of his office, and because it's an official email, we guessed it that he's obviously using the email login from his office location. We put that location, and boom, we were logged in, guys. So this was a very big win for us. Obviously, we then once logged in, we the first thing was to go through the Google Drive and images and documents. So we started looking for more information. Being a red team, our activity is goal based, right? We and the VC's goal was that you need to show us the deepest impact. What could a real hacker do if he was to hack us right now? A real hacker. So being keeping that in mind, we could not stop, because this was not enough. A VC, for a VC, customer data is important. Although yes, getting into the network is also important, but a customer data would be more critical if we compare these two things. So we started digging more into Google Drives, and we then thought that they have a lot of applications connected to it. Yeah, sorry. So we had Sisense, we had Splunk, we had Datadog, and so on connected to the drive. But this was not enough. We could not find a lot of juicy information here. So we went back to the forum, and we tried the same thing for different users. And to our surprise, the next account we got was actually the IT admin. We got into the Google admin of that particular user, which then this was game over, guys. We basically had admin access, and the IT admin was using the default password.
Yeah, this
And
because he created a backup account. This was not the main account, of course, but he
obviously,
had
yes,
created a backup account And for the backup account, the password was default. And because we were just brute forcing the usernames and scraping them from the forum, this was not used, but this had a lot of access. And this was basically a big lottery win, where this IT admin, of course, has access to everything in that particular investment of the VC. Yeah.
And you can see in the screenshot that they had about 900 employees. So we had access to all of the 900 emails, and we could basically reset a password, log into them. Now the fun begins, right? You get an IT admin, you start looking for things here and there. We started exploring Google Drive, we started exploring emails, we started logging into, because we had all access pass, we can do whatever we want from the VC. And so funny thing that once we started doing all of this, we found a lot of juicy information, the Excel files. And then we basically the next slide, Aman, if you could show it, it was that's it. So we found a lot of passwords to internal panels. So you can see, because it's internal, a lot of people usually use a simpler password, because it's behind the VPN, it's in an internal network. But we started getting it. And then so basically this was one part, right? Then we got Google Analytics, and similarly we got their domain SSL access, we had their SSL certificate. We also had a list of all the active domains which they were using, and whatever their passwords were, and the entire host which they were using. We got a lot of access, but still not enough. For a VC, our customer data would still be very, very critical, right? So this was good, but this was not very good. So
Yeah.
parallelly, now what happened was, this was us, one team doing all of this, and then parallelly, because we worked in teams and we have an internal war game, parallelly this was another team doing activity.
Yeah.
Aman.
So while one team had already cracked an investment, and I would say gaining access, sorry, to the email of all the employees was one win. So one investment was down, and we started, like I personally started digging into, other investments, other applications, and see what can be done. And one of those applications was a simple food ordering app, wherein uh, the entire login was mobile number based. So you had to enter the mobile number of the user, and then it would generate an OTP for login. And at this point, obviously, the first thing that strikes us is, could we do maybe a brute force for the OTP? Sorry. So that's what we tried to do. But basically what was happening was, for every login attempt, of course, only three, like for every login session, only three attempts were being allowed. And that's where I started digging in as to understand how exactly have they implemented this, because I saw something fishy, and something that could, like, that didn't look right. And I was correct. The what basically the application was doing was, every time you attempt to log in, it generates an auth key, and for that particular auth key, uh, you could only attempt the login three times. So every login required an auth key, and per auth key you could only try it three times. But the problem was, I was able to find out the endpoint which was being used to generate this auth key. So after that, it was pretty simple, because the OTP we assumed was 4 digits. We generated 9,999 auth keys. Actually, we just needed like one fourth of that. But yeah, that's what I did. Generated auth keys, 9999 auth keys, and then with a simple pitchfork attack, was able to, for every auth key, try an OTP, do that stuff, and that gave me access to like the food accounts of any user that I want to. And of course, to our delight, just to give it as a POC, the second account that I got into after mine was, of course, the VC's account. And we sent him a screenshot with his address and his last few orders, and we told him, yeah, we are going to order the pizza that you order quite so often, right? So this was one of the interesting finds. And similarly, we're exploring other applications. Himanshu was also able to find out a mobile iron application.
So for people who do not know mobile iron, it's a MDM device. It is basically used to, for in environments where employees are usually allowed to bring their own devices, and the mobile iron is installed to make sure no data leakage and data protection, happens and all that. But in this case, when we discovered a mobile iron, it was obviously a old version of mobile iron, and this version was actually vulnerable to the injection. And we basically, what we did, because it was an MDM, right, we had to call our point of contact, and we had to verify this. Now this was very critical, and we called them up, and we asked them that, we have this, do you want us to exploit it? But what the response we got was that, this is a demo application, nobody uses it anymore. We just did a trial of this application and we never ended up using it. We are using something else, so there is no data there. You can skip to it, you can skip checking for it. But for some reason, I was curious, so I went in and tried it anyways. And after doing the injection, we basically discovered that thousands of employees were, like, I think a couple of hundreds, actually the hundreds of employees were still using the application. It was still installed on their mobile devices, although they tested the application on these employees. But what we discovered was, like, this application was never uninstalled or discontinued. And you can see that their registration date was very, very old. For years it has been there, and we had access to all the data. So you can see we can actually lock the phone, wipe the phone, install our own malicious app. We could configure the Wi-Fi in their phone. We could actually get access to their Wi-Fi passwords, which are stored on their phone. And we can basically, be it iOS or Android, we had a lot of control over the devices of hundreds of employees. We could basically track anything, what application installed, how much memory are they using. We had complete control of a lot of employees. And to prove it, we actually saw one of the employees. We could track their live location, and he was at a, he was chilling at a pub during office hours. And this was a screenshot we took to prove that, this is actually live and this is your office hours. This employee is probably having a lot of fun. So yeah, that was one of another big wins for us. And moving on, we had a couple of other
Yeah,
wins.
so
Yeah.
moving on then, because we were again had a lot of access to another investment. Again, same employee access, and from there on, you can understand we did the same thing, got a lot of other access about that particular investment, and we move forward. So next target for us was this e-commerce website, and the best thing that we personally like to do with e-commerce is not user data, but finding ways to make payments for free, right? We even have a website called
Yeah, I think I don't know. So, anyways, let me. We can talk about that thing. So, while because we test a lot of payment gateways, we have been doing it for years and years. We have a lot of experience, and doing a red team gives us a lot of experience with payment gateways. And sometimes what we have is we get unique use cases, and some of them are very, very unique. In that case, let me share my screen, and I will show you. 1 second, I'll present the slides. Yeah. So this was a very interesting case where we were able to bypass the checksum. Basically, what was happening in this payment gateway URL was that, once you try to initiate a payment on a gateway, a checksum is being formed to make sure that no data is being invalidated. So, for example, there is first name, there is last name, and there is an amount. So the application usually takes all of this data and creates a checksum out of it, and to make sure that data can be validated when it reaches the server and nobody can tamper with it. And in the same case, interesting case, in this case, what we discovered was basically that the checksum was being validated, but not the data, the order of the data. So in this case, what interestingly happened was, in the last name, what we did was we basically tampered the last name and switched the last name with an amount. And so you can see here in this particular slide that the last name we put an amount of 120 INR, this and including the decimals. So because the data is still the same, right? We just switch the order of the data. The checksum remains the same. And first we initiated the order and then we switched the amount. So the entry in the last name was 120 and the actual amount was 800, and the checksum was being calculated. We basically replaced these two and we switched the data, so the checksum would still remain the same. The server would think that everything is valid, right? Because this was a very, very unique logical flaw in the payment gateway provider. Not really the provider, I would say. This was a flaw in the implementation of the gateway. Because what happens is nowadays, what we have discovered doing all of these pen tests, the thing is that people usually focus on getting live with the production more than actually testing, going through proper security checks and QA checks. Because companies focus on getting the application live as soon as they can because of the revenue and all of these things. They obviously have a pressure from the team. So in this case, this check was skipped and the gateway was not properly implemented. So this was a very unique find. And yeah, so you can see we basically switched the numbers, and you can see the amount was still there. The checksum was valid. We go ahead and did the payment, and it was successful. So this was like a huge win for us. The VC was very, very impressed. Even because nobody thought of the use case. Usually, payment gateway flaws are like you basically bypass it. You do a response tampering. You do a for example, if there's an order going, there was a very, very old flaw called $1 flaw, where in PayPal. So when you used to do a transaction, you basically switch the amount before sending it to the gateway. For example, if the product is $100, we used to switch it to $1 and the payment would still go through. Similarly, there was another unique case in one of the food ordering apps where the interesting case was, for example, you're ordering one pizza, right? And the cost is $100. This guy, actually what he did was, he simply, instead of changing the amount, he tampered the quantity. He switched the quantity from 1 to 0.1, and interestingly, when the order was processed, the amount actually got so you cannot deliver 1/10 of a pizza, right? But the amount was generated in that way. So that was another very cool bypass, which was discovered, I think, a year back or so. Similarly, moving on, so after these payment gateways, now these things started to get interesting, right? We had a lot of data from a lot of customer personal information from one point of application. Then we had a payment bypass, which had a huge monetary impact. And people who could exploit this in mass, they could actually do a lot of damage. And so similarly, getting back to another team which was still exploiting the internal network and trying to get more information out of it, because being a VC, he was still more concerned of the extreme impact of what could happen. So we were still, because it's a goal-based activity, we were still continuing with it. And this, coming back to the previous team, this team discovered actually a Jenkins script console. And so I'm sure all of you must have heard of it, that Jenkins has an option of script console where you can actually create your own scripts and execute it. And if that is enabled, it is now disabled by default, but in case it's still enabled, what happens is you can execute your own scripts and you can get access to the entire the server. So this happened with us. We were able to exploit it and gain access to the server. And you can see that we have the entire access, and we could actually read the SSH key files from there. So from that point, we started basically digging for more and more information in the server. Now this was all about, once we have one access, we use it as a pivot point, and go deeper inside the network. And that's what we started doing. Reading the config files, we basically got us access to more databases inside the network. You can see here the passwords and databases were there. And similarly, what we discovered was VPN credentials that was stored there for some reason. We don't know why it was there, but they were still there. But now this gives us a huge advantage. Instead of uh, basically pivoting from one initial entry point, we were now directly logging to the VPN and getting access to the network directly. This gave us a huge advantage, and we had access to the entire network instead of going from one point and jumping to another inside. Things went kept going. Another team discovered Redis server, which basically allowed, which was running without any authentication. So let me, I think, switch it to slideshow. Yeah, this must be better. Yeah, so because it was an internal server, what happens is, this is a very, very common thing which people do is, because everything is internal, people usually do not apply authentication to it, and things like that happen. So this, the same case happened here. We were able to, because the Redis server was running without authentication, we were able to exploit it and upload our own SSH key. If you guys can Google about it, you will see that it's a very, very famous exploit, where basically you can upload your own key and rewrite it inside the server's SSH folder, and you'll get access to the entire Redis server. And this happened with us. We got access, and here you can see we got root access to the server. And then again, our goal was to look for data and penetrate deeper inside the network until we actually reach either the DC or something which is a game over point for us, right? The goal then stops. So similarly, going into the Redis server, we discovered a lot of Docker configuration files, and which were stored there, Docker CFG files, and the password, if you guys know it, Docker CFG files usually have the password stored as a base64 encoded password. So we decoded that, and we got access to their entire Docker system for whatever things they were running. You can see here the password was base64 encoded. We decoded that. We got access to their entire Docker, a list of all the Dockers which were running, and basically some of them were production servers, some of them were payment servers, some of them were APIs. So we started getting access to all of this. Now the things were starting to get interesting, and we started getting access to more and more data. Here comes a very interesting case. Another team discovered another Redis server, and what happened was, the same exploit was done. And when we started looking for more data, right, we could see that we could not find anything interesting. Like we tried to look for inside, we tried to do a recon inside, we started, I don't know, we looked for networks internally they were connected to, and all of that, but we could not find more information. Interestingly, then Aman had this idea, and thanks to Aman, this idea was Aman's, and we ran the history command, and so the developer who was using it, interestingly, had the entire SQL query along with the password and auth tokens. He ran it in one go, and it was stored in the history. And once we ran the history command, we got access to the entire production database. And if you see the count, we had access to more than 14 million users records, like, and they were customer records. So these were data which included the actual paying customers on, I believe this was an e-commerce website or system, I think, company, and they had over 14 million active customers in the database, and we got access to that as well. And so similarly, interestingly, what we did was, parallelly, we were also hunting for S3 buckets, because you know, looking at the transportation app, which these VCs owned, we got to know that there was a system where you had to, if you want to drive, consider it like an Uber, right? And this was an Uber for trucks. Basically, you could transport your, if you are switching home from one city to another, you could transport your stuff from one city to the other. And studying about the application, we discovered that this application, actually, a driver who was driving the truck has to do a complete like a personal KYC, know your
KYC,
customer
yeah.
process. Yes, where he had to upload his personal ID, driver's license, and passports, and so this bucket was actually configured to be like we had public access. So this bucket was allowed to so anybody in public could actually browse the entire information stored there. Sorry. So you can see that when we started going and we used AWS CLI, we basically started with the ls command, and we found two folders, developer and production, and we then went into dev, and then we went into production. We had access to all the licenses, their address proofs, their vehicle registrations, what owner controls what truck, what vehicle is it, the photos of the vehicle, and I believe this was another 6 million information or so. That was the approx count of the customer data. Oh, 3.2 million. I'm sorry. So yeah, we had access to 3.2 million more records of like PII data of the customers. Now, Aman had this interesting SQL coming to very tricky SQL. So what happens sometimes is that a lot of people rely on tools. So interestingly, when we have an SQL, a lot of people I would assume, and I would completely agree that. In fact, I have also done the same thing. I usually get an SQL map to run it, and we take it from there. And I think Aman will tell you more about this case scenario where SQL map actually failed.
Yeah, so of course there are every day there are hundreds of cases where SQL map fails, and me personally, these guys call me SQL map myself. I'm generally doing the SQLIs for them manually because I'm more of a manual exploitation. I prefer manual exploitation because we get more visibility and there is less noise, of course. And basically, the again SQL map fails all the time. We know that, especially people who are doing manual injections know that there are a lot of scenarios where you are able to do maybe a time-based blind injection or a third-order injection, like a server-side, like SSRF-based injection, but everything is time-based and or it is blind. So you have to uh, you cannot do it manually, right? You don't have the time to dump the data manually, and you need a SQL map for at least the automation part. So of course, at this point, this was one of the cases. One of the like the one of the ways that I could have done over here is, of course, write a simple script to dump this entire thing in Python and code the entire blind injection logic. But of course, I'm lazy AF, and I thought, okay, I'll open up SQL map and patch it, fix it. What are the issues? And as anybody should do is I hooked up my SQL map through burp to basically get an understanding of what exact requests are going, how SQL map is concluding that the SQL injection does not exist. And I scroll through, of course, for a single 1 = 1, 1 = 0 comparison. SQL map makes, I think, around 80 to 150 requests, to conclude whether the Boolean part is working or not. And I dug through all the requests that SQL map was sending to basically understand why was the logic not working. And I found it out what was the problem. And I located the issue in the code. This is, by the way, SQL maps code, and you can see 797. This was the problem area where I don't know why, but there was no equal to sign in the condition where SQL map was sending the data. And if this statement was not true, SQL map assumed that the SQL injection was a false positive. And of course, from here, I just simply commented out this line and ran SQL map again, and it was able to pick up the injection, and we dumped this data. Why this was important was this was very interesting data, and more importantly, the permissions on this SQL server were root. So that was a big win. Where this was running as anti-authority, and that was more important than the data inside it. Similarly, there was a very interesting case of another SQL injection. In this case, this was in password retrieval. Yeah, I don't think I've seen many of these, but this was there. where I figured out that the injection was there. At this point I could have done a blind injection or something, wherein the employee code had SQL injection. And what I did was I basically realized that if I can actually union this entire query to, try to imagine what exactly would be the backend query to reset the password. And I imagined, of course, at some point it will need an email address for that employee ID and send an email to that. So that's what I did. Himanshu, go to previous slide. Um that's what I did. I unioned my test email address in every spot in the SQL query, and that's what happened. I actually got an email on that email address. If you go to the next slide, Himanshu, basically I got an email and I found out, okay, no need for a blind injection here. I could actually send password reset emails, and then username, which is again controlled by a field in the SQL query to which I can union to. I just put the username there, and in the password reset email, I was able to start, dumping the data from here. So I could just do union stuff and get table names, column names, and data all over here. So this is again one of the very interesting cases not seen quite often. And this from here on we were able to get onto the server backend and get a lot of critical information, gain access to that. Meanwhile, what I was also doing was looking at this application. I think, Himanshu, have you covered this?
We covered in very brief where we got the data of the users through buckets. I believe we are
Yeah.
short of time, so we will
Yeah. So
quickly go through of the another bug.
this is the same application, Uber for trucks. In this case, I again try to reverse engineer what exactly is the payment mechanism, and I simply saw, so when you cross a boundary, a territorial boundary, you need to pay something called a toll, which is a tax, like a boundary tax, a road tax. And in this application, of course, when we are doing payment tampering, you generally try to tamper the amount, and in this case those things were of course not working. But what I did was I set a negative toll amount, and the toll amount was being calculated from the front end. So again, changing the toll to negative, the estimated fare became zero because I set a negative toll, just like setting up a negative tax or a decimal based quantity, right? Things like that. And this is what the driver saw to collect 0 rupees. And yeah, that was it. So this was again one of those bypasses, payment bypasses, right? We have already covered the network. This is the same network that we got in through the SQL map, and anti-authority system gave us access to the internal servers. Now, yeah, Himanshu, you please continue.
This is like this was the best moment of my life, I would say, during this entire activity. If you guys have done a red team or an exploitation, it is obvious always advised to migrate to a different process. Once you get access to a server, you look for a process, you migrate to a different process. And in this particular case scenario, what we were doing was we were trying different processes to inject our payload and migrate to that for stability basically. And we tried explorer, we tried login UI, and our payload kept crashing. So finally we thought we tried, and we tried to locate the reason of what was happening. Is that we saw that a McAfee host intrusion prevention was running on the system, and that is why our payloads kept dropping, our connections kept dropping. So this was somebody in the team gave us the idea to let's try to migrate on the same process. So we basically tried to inject our payload into this process, and this worked. So McAfee HIPS our malware was running in parallel in the same process of the HIPS system of McAfee. And it was very stable. So this was the best moment. And so this was the end goal. We used Mimicache and PowerShell to gain access to the entire network. We had access to the almost entire network and everything. And this is when we decided to conclude the activity. And we were almost doing that. We found another reporting portal. So for VCs, we discovered that they have a central portal where they all the revenues from all the databases, all the users, they came, and the reports were there on a central panel. There was an SQLi there, And when we started exploring the SQLi, we found a configuration file because this portal was connected to all his investments and it was getting the data combined from everywhere. We saw the login passwords and we got access to all the databases in the entire VC's capital system.
Yeah,
So we had access
and
to everything.
interestingly, it was the VC should not have access to customer information, and he did not. The panel had no feature to show him that, but it
Yeah.
was connecting to the databases of his investments to get some stats. And the problem was
Yes.
the privilege of the user, which was being used to fetch this information, actually had access to all of the data in those databases. So when we actually gained access to the admin panel, there was just some numbers and stats there. But when we were able to use this configuration file and the credentials inside, these credentials were not restricted down for the particular usage, and we started dumping data, and we got access to databases of a lot of his investments just because this guy had created backdoors to get some stats. Bad coding, I don't know, bad architecture. Yeah. And
So
that sums it
I
up.
guess
Yeah.
we almost are out of time, and so things we learned, wrapping it up, is that please have two-factor authentication on emails always. Please do not share password through the emails. It's a very bad habit to run database surveys as root, because even though your intent is to show the data as read only, but somebody who gets access can actually run system level commands. Business logic process, always re-verify it. It should be carefully tested before putting the app on production. Then clear command history is like the basic one. You should always clear your command history. Company name @year is definitely not a good password, and we would assume to say that McAfee endpoint security is definitely not worth it. So in general, these tools are usually good. It's the problem lies with the configuration. If you are not configuring them properly, that's where the problem arises. And this was the case we showcased was a classic case of misconfiguration. The tools are good, but the way they are configured is where the problem usually arises. All right, so guys,
Yeah.
if you have any questions, please feel free to ask. And sorry for the technical glitch we had in
Yeah, I
between.
had a massive power cut, so I had to switch to my hotspot. Yeah.
Yes. So these are, you can feel free to reach out to us on LinkedIn, Facebook, Twitter. And I guess, do we have time for the questions right now? We can take some questions.
There are no questions at this point, Himanshu. So I think that concludes this session.
Okay. So
Thank you,
I guess we
Aman,
can conclude this.
and thank you, Himanshu, and thank you for watching.